So what we just discovered in using the sieve of Eratosthenes, probably totally mutilating that name, but anyway, you guys get the point, is that we found all the prime numbers. Now, I'm going to tell you a little story, okay? You're all fancy business people, and you have a company, and your company sells different lengths of licorice, okay? You all own a licorice factory. Now, if you put the licorice in the size 1 machine, it will come out as 1 unit long. But you can stretch the licorice to size 2 by feeding it through the times 2 machine, and it will become twice as long. What will happen if you put it in the times 3 machine? Oh, and what about in the times 4 machine? And you tell all of your clients, you say to them, hey, I have a deal for you. I can make you any size licorice up to size 100. I have 100 machines. And you're rich and you're famous, and then all of a sudden, your machines start breaking. And what we're trying to figure out is the machines that are of prime importance, okay? So one of your employees says, well, hey, you know what happened? The 10 machine just broke. And one of the employees said, oh, well, I have an idea. If we feed it through the times 2 machine, and then in the times 5 machine, it will become twice as long, and then it will become 5 times as long as it was before. So 2 times 5 is 10. 2 times 5. I might switch to pen for this. It's a little easier to write with my numbers, because this one doesn't have to be as color-coded. Now, all of the machines that you have circled are the ones that are of prime importance, because they're prime. Those machines can't break, but every other machine that is not circled on your page can break. Okay? If the 4 machine breaks, what are you going to replace it with? 2 times 2. So 2 times 2 can also be written as, remember we were talking about exponents the other day? 2 to the second power. So you can write it either way. You can write 2 times 2 or 2 to the second power. Now I'm going to encourage you to use exponents, because here's another situation. What if the 8 machine breaks? You don't have a 4 machine anymore. What are you going to replace the 8 machine with? 2, it's going to be 2 times 2 is 4 times another 2, right? So 8 is 2 times 2 times 2, 2 to the third power. And if you're not sure, take out your calculator and double check it. If you multiply 2 to the third power, or 2 times 2 times 2, you will get 8, right? What if the 9 machine breaks? Can you replace it? What are you replacing it with? 3 times 3, or 3 to the how many 3's? Second power. What if the 6 machine breaks? Can you replace it? What are you replacing it with? 3 times 2. Now that's not you can't use an exponent there, because there's only 2 numbers that are the base, right? Neither one of the numbers is repeating. They're only happening one time. So technically these are both having an exponent of 1. Okay, what if the 16 machine breaks? Who can tell me what the 16 machine would be replaced with? So it would be 8 times 2, but remember our 8 machine is gone. Oh. And the 4 is gone as well. But what do you do to 8? Okay, let's go back to 16. 16, you had 8 times 2, right? But the 8 got replaced with the 2 to the third power. So the 8 is the same thing as 2 times 2 times 2, right? Times another 2. See that next 2? That's so many 2's. How many 2's is it? So what do we write? 2 to the... Exactly, 2 to the fourth power. You might remember those numbers from the birthday trick the other day, right? The powers of 2, remember on the first day I said the number sequence went 1, 2, what did it go? 1, 2, 4, 8, 16. What would happen if you double 16? You get 32. So what do you think 32 could be replaced with? 2 to the, it's one more 2, right? Because you doubled it. 2 to the 5th, because one more 2 would be 5 2's, right? Now if you double 32, what do you get? 64. So let's cross out the 64 machine. Any guesses what the exponent will be there? 2 to the 6. 2 to the 6. I don't have my calculator handy, but if you do, try 2 to the 6th power. Oh, thank you. Look at that. In a math class, imagine that. I can just borrow a calculator at whim. Okay, so let's double check it. If we go 2 to the 6th power, we get 64. Okay, 2 to the 5th power, we get 32. 2 to the 4th power, we get 16. 2 to the 3rd power, we get 8, and you already know 2 to the 2nd power is 4. Okay, that's the prime factorization of those numbers. Let's pick another one, and then I'm going to have you keep going with this. So pick another one that you want to break down. 77. 77 is broken. What does it get replaced with? 11 times what? 11 times 7. Now those can't be, the exponents here are 1. You don't have to put the first power, but that is implied. That's something that a lot of people don't know, that something, if there's only one of them, it's to the first power. It's not going to affect your answer at all, okay? It's just the same thing as 7 times 11. And that's because 7 is prime and 11 is prime. Okay, one more because I can't stop. I'm having too much fun. 12. Let's cross out 12. Can 12 get replaced? So 3 to the 2nd power would be 9. 3 to the 3rd power is actually, okay, let's try 3 to the 3rd power. 3 to the 3rd power is 27. Why is 3 to the 3rd power 27? Because 3 times 3 is 9. 9 times 3 is 27. Oh, so you actually found one. 27 is a perfect cube. We call it a perfect cube. When it's to the 3rd power, it's a perfect cube. When it's to the 2nd power, it's a perfect square. So cube, 3rd power, we're going to get to all that, okay? 12. 12, just give me two numbers that multiply together to give me 12. 2 and 3, okay, 2 and 6, you're right, 2 and 6. Okay, so let's put the 2, and then 6, we already replaced the 6. So the 6 was 3 times 2, right? So 3 times 2 times 2. Remember, we can't use any composite numbers here. We're going to only use prime numbers. So another way of writing this is 2 to the 2nd power, since I have two 2's, times 3. Is 13 prime or composite? Prime. Is 14 prime or composite? What's it get replaced with? Times 2. Good, and we can use both of those numbers. What about 15? 3 times 5. Those are both prime. What about 17? Keep it or replace it? Keep it. It's prime. It's of prime importance. Okay, 18. You can get rid of it. What can you replace it with? 9 times 2. Okay, so I'm going to put the times 2 because 2 is prime, but let's look at 9. 9 is 3 times 3. So you can either write it as 2 times 3 times 3 or 2 times 3 to the 2nd power, because that's the same thing as 9, right? That's a perfect square. Can we replace 20? And what do we replace it with? 2 times 10. I love 2 times 10. 2 times 10, but we already replaced 10. So it's going to be 2 times 2 times 5, right? Because 2 times 5 is the same thing as 10. What's another way of writing that? Okay, so I think that's 10 minutes is good. I'm going to come around right now